Calculus is arguably the most important topic in maths. It forms the foundation of so many questions that you could possibly be asked. One time in one of the HSC papers, if you count up all of the mark allocations, you would have found that in one of them, the paper was literally 50% worth of calculus knowledge. So this video alone is going to be forming your foundation so that you'll be able to tackle those really tricky problems later on. So this is going to be Differentiation 101. Hello and welcome, I'm Jessie. These are my study notes. I break down maths in a way that actually makes sense, and I also give study and productivity tips to help you navigate high school maths. If you like what you see and you're ready to enter your study era, hit that subscribe button and let's get to it. Now, the first rule that we look at and everyone typically knows is the power rule. You might not refer it to it, but it's the rule where if you bring the power down, you reduce it by 1. So we have y is equal to x to the n, just to generalize. Then what you do is you bring the n down and then you reduce that power by 1 to get n minus 1. Now, just a little bit of terminology. When you have your original function, that's your y. When you perform differentiation, that's the process, you end up with the derivative. Okay, so for example 1, we have differentiate this rule over here. So you can see that they are individual terms or powers of x, so you can just differentiate them separately. So if I differentiate 6x to the 4, the power of 4 comes down to the front. You can write it as 6 times 4, but that's the same thing as 24, x, and then the power reduces by 1. You bring the 3 down, times it by the negative 2, you get negative 6x, reduce it by 1. Bring down the 2, you get 8x, reduce it by 1. You can write x to the power of 1, but you can just write x. And whenever you have a constant, then the constant goes away. You can also think about it as, technically when you have a constant, you have x to the power of 0. So if you times 0 down to the front, it just becomes 0, so the constant goes away. Okay, example 1 done. Now, example 2a, what about if we want to differentiate something that looks like this? Okay. Now, notice how, yes, there is still like x with a power, but it's in the denominator. So in order to use this power rule over here, you always need to put x in index form, which means it needs to be in the form of x to some power, okay? And x has to be at the top, can't be on the denominator. So what we have to do first is we need to change this form into 2x to the power of negative 3 using negative index laws. And then now that it's in this form, we can successfully differentiate it, bring the power down, that's negative 6. If we reduce it by 1, that's going to give you x to the power of negative 4. Okay, careful there, it becomes more negative. Now, a general rule of thumb I like to tell my students is leave your answer in the form of what it originally was. So if they gave it to you where x is in the denominator, answer it with x in the denominator. So that means we're going to end up with y is equal to negative 6 over x to the power of 4. Lovely. All right, now, similar thing going on. We have y is equal to 3 root x. So what we're going to do here is we're going to also have to get it in index form. So to do that, we're going to borrow some laws from the index laws, which says that if you have a to the power of m on n, so this is a fractional power, then you can rewrite it with as a surd, where the surd is anything with like this radical sign. So a is going to be our base that goes on the inside, m is on the top, so m goes on the inside, and then whatever is on the bottom goes on the outside. So that means it's going to be the nth root of a to the m. So for this one over here, you can think about it as it's a square root, so it's going to be 2 on the outside, x to the power of 1, so we get 3x to the power of a half. Or if we differentiate that, 3 times a half is 3 on 2. And if I reduce that power by 1, don't touch the calculator just yet. I want you to get used to the fractions because you do it so many times, it kind of wastes time having to put in the calculator. If you do minus 1, you can't do that because they don't have the same denominator. So instead, minus 2 on 2. 1 minus 2 is negative 1 over the same denominator of a half. And then same principle, if they give you the question as a surd, answer as a surd. So to convert this back, you can see that we have a negative power, so that brings the x down to the denominator. And then we also have a half, so that makes it a square root. So we're going to get 3 on 2 times 1 over root x, or just simply 3 over 2 root x. So now we're going to be looking at how do we use chain, product, and quotient rule. So these three rules, along with the power rule, are like the absolute foundation of derivatives. And then later on, when we start unlocking different functions like exponentials, logs, trig, we are also still going to be borrowing these principles. So it's really important that you have that solid foundation. So over here, I have all the three rules written down. And we're going to look at the different formulas and when to use them. So chain rule is used when you have something in the form of f of x to the power of n. We call this a composite function. A composite function is just this fancy word to mean you have an inner function and you have an outer function. You typically use these when they're in this form. So you can see we have 2x plus 3 is the inner function, outer function is the power of 5. Even something like this, x plus 1 inner function, square root, or power of a half as the outer function. And the formula for this is really intuitive. It's so similar to the power rule. So what you're going to do is you're going to treat this as like x to the n. So you bring the power down and then you reduce it by 1. But since this is chain rule, we have an inner function. You also need to times it by the derivative of the inner function. Okay, now before I explore how to use this, I'm just going to go through each of the rules and then I'm going to, boom, go through all of them. Product rule is when you have a product of two functions. We call them u and v. So the derivative for this is v u dash plus u v dash. Textbooks might write it a bit differently, like u v dash plus v dash u. Doesn't matter, guys. As long as you're taking turns differentiating and then it's a plus. So I associate product and plus together because times and plus go up. All right, and then now you use this if you have a product of two functions like x squared is one function and then x plus 5 is the other. Or we can have e to the x is one function and then sine x is the other one. And then the last rule is quotient rule. So quotient rule is when you have a division of two functions. That's what quotient means. So u is always at the top, alphabetical, v is on the bottom. And the rule for this is vu dash minus uv dash over v squared. Now, this is very easy to forget. You can look through the reference sheet, but I almost never encourage students to rely on the reference sheet. Think about how many times in an exam you're going to have to flick through looking for it when that time could be spent actually answering the problems. So my little neat trick that I get my students to remember is I get them to recognize that if you look at the V's are on the outside forming a bigger V, okay? All V's on the outside forming a bigger V. And then the last thing to also think about is that it's a minus because quotient rule, and you just differentiate u first because alphabetical, okay? And then when you just think about those rules in mind, you don't have to keep being like, oh, what's quotient rule again? Or you don't have to look through your reference sheet. Okay, so examples of this is when you have something like x squared divided by x plus 2 or cos x divided by x squared. Lovely. So that's our little overview. Now let's tackle some problems. So for the first example we're going to be looking at is differentiate y is equal to 3x plus 8 to the power of 5. So I want you to think, which rule do we use? It is going to be chain rule. We've got the inner function and the outer function. So the way we're going to do that is first you bring the power down, bring it to the front, reduce it by 1, and then the last step is to times it by the derivative of the inner function, which is 3. And then just to clean it up, I like to combine my constants, bring them to the front. 5 times 3 is 15, 3x plus 8 to the power of 4. Lovely. Next, we have this, differentiate y is equal to 2 on the square root of x squared plus 1. Now, which rule do we use here? You might think we use quotient rule because when a student sees a fraction, they're like immediately quotient rule. But you only use quotient rule if you have something with x at the top and something with x on the bottom, okay? In this case, I only have x on the bottom here. So instead, what I'm going to do is I'm going to change this third to a fraction. So it's x squared plus 1 to the power of a half, but I'm also going to bring it up. So we get 2 bracket x squared plus 1 to the power of negative a half. So now that I've transformed the original question in this form, can you see now it's going to be chain rule once again? So now if I were to apply chain rule, bring the power down, times it to the front, that's going to give you negative 1. And then if you reduce the power by 1, if you minus 2 on 2, you get minus 3 on 2. And then the last step is just to rewrite it in the original form. We're going to have -1 over the cube root of x squared. Oh, actually, no, that's the square root. -1 over the square root of x squared plus 1, all cubed. If you guys want a copy of the PDF, kind of like collecting a bunch of study notes for this particular topic, you can head to the link in my description box down below where you can access all these study notes. Make sure you share them with all your friends. Sharing is caring, and that's how we go through this tough period of our lives together. Yay! Next, example 6. So differentiate y is equal to 4x times x squared plus 3. Now, which one of the three are we using? It is product rule. You can see that we have the product of this function times the product of this function. All right, now the way that I set up product rule is I like to write out all my little bits and bobs. So u is equal to 4x, u dash is equal to 4, v is equal to x cubed plus 3, and v dash is 3x cubed. Now the formula for this is going to be v u dash plus u v dash. Any order is fine. All right, so now if I plug this in, we got vu dash, so this times this. So we're going to get 4 times x cubed plus 3 plus uv dash, so that's this times this. We get 4x times 3x squared. Now, typically, I like to expand it and simplify it because you could, you want to further simplify this expression. So this is going to become 4x cubed plus 12 plus 12x cubed. And then if you combine the first two terms, we're going to get 16x cubed plus 12. Next, example 7, differentiate y is equal to x squared plus 3 over 2x minus 3. Can you guess? Quotient rule, right? So that's going to be u on v. So I'm going to set this up the same way I just set up product rule. So u is going to be x squared plus 3, u dash is 2x. V is 2x minus 3, and v dash is just going to give you 2. Now let's see if you remember the formula for quotient rule. V is on the outside, differentiate u first because alphabetical, and then a minus. So that's vu dash minus uv dash over v squared. Now in that case we get v is 2x minus 3 times u dash is 2x. I'll write it in this order. And then minus u times v dash, that's 2 times x squared plus 3, all over v squared, 2x minus 3, all squared. Okay, lovely. And then now I'm going to expand the top. Always expand the top and simplify. 4x squared minus 6x minus 2x squared minus 6. And then if we collect the like terms, you can see that these two are like terms. So then we end up with 2x squared minus 6x minus 6 all over 2x minus 3 all squared. Perfection. Okay, and the last one, example 8, differentiate y is equal to 3x minus 1 to the power of 4 over x squared. Now you can see what rule are we using? Hopefully the most obvious one is quotient rule, but there's actually another rule involved. It's going to be chain rule. So we have a combination of two. So first let's set out our equations. U is equal to 3x minus 1 to the power of 4. U dash, using chain rule, is going to be 4 times 3x minus 1 to the power of 3 times 3, the inner function. If I just combine the constants to clean it up, we get 12 bracket 3x minus 1 all cubed. V is going to be x squared and v dash is 2x. All right, so if we write down our formula once again, v is on the outside, u dash before v dash. And if we were to plug this in, we're going to get v times u dash down here. So if I times those two, I generally, when I figure out like how to write them in, I put like the things with less, like singular terms at the front and then binomials or two terms later on. So I'm going to do 12 times x squared times 3x minus 1 all cubed. And then if I times the other two, we are going to get minus 2x, 3x minus 1 to the power of 4 all over x squared squared. Okay. Now remember I said in the previous example that you always want to expand your numerator, but if I were to expand this or this, I'm going to be here for a while. So you could leave it, but what I'm going to do instead is I'm going to factorize the numerator because I'm going to notice there are things in common. I can notice that they both have a factor of 2. I also know they both have a factor of x. And they also both have at least 3 lots of 3x minus 1. So I'm going to factorize that entire thing out. So we get 2x and then 3 lots of 3x minus 1. So now we are left with, in the first term, we're left with just a 6x. And then in the second term, if you look at these numbers, these are the same, except for the negative. But this originally had 4, we took out 3, so we're actually left with 1. And you please put it in brackets. And that's going to be all over x to the 4. So now as the final step to do, I'm just going to expand this bracket here. Leave the other form factorized. If we expand it, we're going to get 6x minus 3x plus 1, which just simplifies to become 3x plus 1. All over x to the 4. Okay. And you see the power of factorizing is now you can notice that we can cancel out one more lot of x on the denominator. So this would technically become 2 bracket 3x minus 1 cubed, 3x plus 1 all over x to the power of 3. Wonderful. All right, that is it, guys. I really hope that by the end of the video, you would have gotten a really good understanding of the basics. And then now that you've got the basics down, we can tackle all of the other rules, which we'll still need to use this stuff in. All right, thanks, guys.